Black holes are mysterious, massive, and far away. This makes them extremely fascinating for experts and everyone else. We now want to learn more about these objects, as well as neutron stars, which are baffling too. How can they be detected from Earth? When was the first black hole discovered? So now I can only say, I'm Floating Brick, and we will soon reveal the mysteries of massive objects in our universe. Formation of black holes and neutron stars. As I explained in the video about stars and galaxies, if you haven't seen it yet, watch it afterwards to know everything like an expert. So black holes and neutron stars are formed after a supermassive star died. This occurs in a massive explosion known as supernova. The volume gets smaller and the density increases. Consequently, gravitational attraction increases, forming a heavy core. This is how these objects form, although it's not known when the first black hole formed. One theory even suggests that they formed immediately after the Big Bang, but this will be proven in the future. What is a black hole, and what about it makes us baffled? Black holes and their characteristics. Black holes are extremely dense. They are surrounded by gas and dust, called accretion disk. Additionally, black holes have an event horizon, the border beyond which nothing can escape, not even light, which is the fastest in the universe, traveling at 300,000 kilometers per second. This is why black holes are black. An effect that occurs when something gets too close to a black hole is called spaghettification. This tidal effect, caused by a very strong gravitational fields, stretches an object, for example an astronaut, like spaghetti in the direction of the black hole. Spaghettification occurs because the gravitational force increases as the distance decreases. Since the feet are closer to the black hole than the head, spaghettification appears. Spaghettification is a kind term for a horrible death, coined by Stephen Hawking, who was a pioneer in the field of black holes. However, it should be noted that there is much about black holes that we don't know. Perhaps the future will reveal what they are made of. We have talked a lot about black holes, but neutron stars are interesting as well, so we are gonna dive in right away. Neutron stars and their characteristics. As I said, neutron stars are also formed from the dust and materials of dead stars. These objects are extremely dense. More than the mass of the Sun fits into a globe with a diameter of 10 to 15 kilometers. If you drove this distance at 100 kilometers per hour by car, it would only take 10 to 15 minutes. Incredible, isn't it? Due to their extreme pressure, electrons and protons fuse to create neutrons. This is why the extraordinary star only contains neutrons and is called a neutron star. Newly formed neutron stars have extremely strong magnetic fields, and most of them rotate very fast. Yeah, very fast, completing hundreds of revolutions per second. These stars seem to break every world record. No, you have to say universe record. Neutron stars beam radio waves from their magnetic poles, which can be detected on Earth if they are pointing in our direction. However, they can also emit jets of gas and X-rays. But now the question is, how do we know that there are black holes and neutron stars out there in the universe? Detecting massive objects. Black holes already were predicted by Albert Einstein, though his general theory of relativity in 1915. However, it wasn't until 100 years later that LIGO Laser Interferometer Gravitational Wave Observatory detected gravitational waves, which Einstein had also predicted. Gravitational waves are ripples in the fabric of space-time, emitted when, for example, black holes orbit and merge each other. 2019, researchers from the Event Horizon Telescope took a photo of a black hole silhouette, making a significant milestone in black hole research. Black holes and neutron stars can also be detected by X-ray observatories on Earth or in space, as well as by tracking the objects that orbit them. Another method is the detection with gravitational lensing. This technique is also based on Einstein's theory of relativity because, like every other object, light is attached by mass. So if light from a star in the background passes a black hole or a neutron star, its direction changes slightly. The star appears brighter on Earth, indicating the presence of a massive object. I know, it is hard to imagine, but it works like a magnifier. In conclusion, even though black holes are common, we do not know everything about them. There are still many unknowns when it comes to fully understanding black holes and neutron stars. So perhaps you out there will reveal their mysteries in the future. If so, let me know and I will make a video about it. That's it for today's video. I'm sure you have learned something new. Share your thoughts in the comments, like the video, click on subscribe, and if you want to get a notification of every exciting topic about our universe, ring the bell so you don't miss any video on this channel in the future. If you did everything, I say welcome in my universe. You will be an expert soon. Until next time, hopefully right now in another video. Yours, Floating Brick.